Hey everyone, welcome back to Wrath of Math. I'm your host, Sean Ian. In today's video, we'll be answering the question, what is a complex number? Getting into complex numbers is like opening a whole new world of discovery in mathematics. It's very cool stuff, so without further ado, let's get into the lesson. So we're very familiar, of course, with the real numbers. We've talked about these. These are your average numbers like -2, negative, say, 1.5, 0, the number pi, 7.31428, any normal number you can think of, that's a real number. We're also familiar with the imaginary numbers, and these are numbers of the form Ri, where R is a real number, and I is the imaginary unit, which has the property that when squared, it's equal to -1. So imaginary numbers are just real number multiples of the imaginary unit. So these are numbers like -2i, -3i, 0i, which is just 0, pi I, 7/5 I. Any real number multiplied by I is an imaginary number. If you multiply a real number by an imaginary number, like say -2 times 3i, then you get an imaginary number, in this case -6i. But if you add a real number and an imaginary number, it's not so simple. For example, we could have 2 plus 3i. And this doesn't simplify to a real number or an imaginary number. This is as simple as we can write it, 2 plus 3i. We can't combine the 2 and the 3i because they're not like terms. So it's not a real number, it's not an imaginary number, so of course it is a complex number. And we'll write about those down here in red. So complex numbers, that's the subject of today's discussion. What are they? Complex numbers are numbers of the form a plus bi, where a and b are real numbers, and I, of course, is the imaginary unit. So with this number, 2 plus 3i, our real number was 2, that's our a value, and then our imaginary number was 3i, so 3 is our b value. Complex numbers have a real part and an imaginary part. The real part is just a real number, and the imaginary part is the real number that's getting multiplied by the imaginary unit. That's why we call it the imaginary part. And this definition, as you might notice, means that 0, for example, is a complex number, because it's equal to 0 plus 0i. And every real number is actually a complex number. For example, 3 is equal to 3 plus 0i. Also, every imaginary number is a complex number. 2i, for example, is equal to 0 plus 2i. So a complex number is allowed to have a 0 real part, and it's allowed to have a 0 imaginary part. But the important thing is, it's allowed to have both a real and an imaginary part. So the real numbers and the imaginary numbers are both entirely contained within the complex numbers. All the real numbers are complex numbers, all the imaginary numbers are complex numbers, but of course there are some complex numbers that are not real numbers, nor are they imaginary numbers. And of course, these are the numbers that have a non-zero real part and a non-zero imaginary part. Numbers like 2 plus 3i. This number is not a real number, and it's not an imaginary number. It only belongs to the complex numbers. And I'll say again, we call 2 the real part of the complex number, and we call 3 the imaginary part of the complex number because it's being multiplied by the imaginary unit. And let me move all of this stuff up. We actually have some handy notation to refer to the real and the imaginary part of a complex number, and we write it like this. Re of the complex number, 2 plus 3i, is equal to 2. This is the real part of the complex number. And then Im, this of course is the imaginary part of the complex number, and that's equal to 3. Now, before we go, let's talk about a visual representation of complex numbers. Remember that we were able to put real numbers and imaginary numbers on a number line. But since complex numbers are made up of real and imaginary numbers, we can't just represent them on one number line, because both real and imaginary numbers need their own number line. So what we need to do to represent complex numbers is actually use a plane. It's like the Cartesian plane, just modified, and this is called the complex plane. And let's move our axes down just a little bit. And so the complex plane is made up of an imaginary axis and a real axis. Generally, the horizontal axis is the real axis, which we denote RE, and the vertical axis is the imaginary axis, which we denote IM. So all the real numbers exist on this real number line, all the imaginary numbers exist on this imaginary number line, and then all of the complex numbers exist in this entire plane. Now let's just mark some units on these axes real quick so that we're able to plot a complex number on this plane. So this here is 1, this is 2, this is 3, this is 4, and then here on the imaginary axis, this first unit is just I. Then this other one, which I'm not going to write because it'd be a little crammed, is 2I. And then here we have 3I, and so on. If we wanted to look at the negative direction, of course, we would have negative I right here. All the imaginary numbers are right there on that axis, which we need in order to represent complex numbers. So let's consider a complex number we'll call z. This is a common name for complex numbers, and we'll say it's equal to 3 plus 2i. Then to graph this complex number on the complex plane, all we have to do is basically treat the real part of the number as the x-coordinate and the imaginary part of the number as the y-coordinate. So we'll go over 3 on the real axis, and we'll go up 2 on the imaginary axis, because we have a real part of 3 and an imaginary part of 2. And so if we plot that point, it's about right there. That is a real part of 3 and an imaginary part of 2. And oftentimes, you'll see complex numbers represented not as just a point, but as a vector, emanating from the origin and going out to the point described by the complex number. So this blue vector here is going from the origin, which is 0, 0, and then it's going up to 3, 2, I. There are a number of reasons to represent complex numbers geometrically like this, but one important one I'll briefly mention is that it allows us to find the magnitude of a complex number. So for example, if we were looking at the real number 3, the magnitude of 3 is just its distance from 0, which of course is 1, 2, 3. And if we were looking at, say, negative 2 over here, and we wanted to know its magnitude, again, it's just the distance from 0, which is 2. But it's not so simple with complex numbers since they don't lie on a number line. So the magnitude of this complex number is actually defined as the length of this vector. And you can find that by using the distance formula to calculate the distance from the origin to this point over here, and you can just disregard the I when you're making that calculation. Or you can do what is basically the same thing, but maybe you prefer it, which is to create a right triangle here and find the length of the hypotenuse. And again, you can disregard the imaginary unit in those calculations because you're just trying to measure the number of units this point is away from the origin. It doesn't matter if they're imaginary units or if they're real number units. And we'll certainly go over that process in another lesson, but I don't want to drag this one out. But that's what complex numbers are. Very cool stuff. A complex number is any number of the form a plus bi, where a and b are real numbers. So complex numbers are sums of real numbers with real number multiples of the imaginary unit. So I hope this video helped you understand what complex numbers are. Let me know in the comments if you have any questions, need anything clarified, or have any other video requests. Thank you very much for watching. I'll see you next time, and be sure to subscribe for the swankiest math videos on the internet. And a big thanks to Valo, who, upon my request, kindly gave me permission to use his music in my math lessons. Link to his music in the description.
So fine today, gonna throw my life away and maybe go see outer space. So it's fine by me.